Hello. Let us start questions on engineering mechanics for mechanical paper in the afternoon session. 3 questions have appeared from the mechanics subject. The first question has come from trusses. Let us look at the question now. The question says a plane truss PQRS where PQ is equal to RS and angle PQR is 90 degrees is shown in the figure. The figure is over here. You are having a roller support at point S and a hinge support at point P. You are applying a force F over here at the point R as shown in the figure. The forces in the members PR and RS respectively are how much? He has given you 4 options. Now this is quite a simple question. Where do I start from? You see, the question is asking me regarding these 2 points. One is PR and the other is RS. But if you look at this diagram, instead of starting straight away for these 2 members, I would rather apply method of joints for this point Q. Why this particular point? The reason is, I see that there is no external load acting on Q and there are 2 members which are mutually perpendicular to each other. Only 2 members mutually perpendicular to each other and there is no other external load. Therefore, it implies that these 2 joints or these 2 members are supposed to have 0 loading. Let us say by method of joints, method of joints, I am starting for point Q, for Q. Now if you see this member or this joint Q, let us say, has over here a force along QR and over here a force along QP, and these are 2 mutually perpendicular members. So I can apply over here sigma Fx is equal to 0. Now what does this imply? If sigma Fx is equal to 0, I can straight away say the only force in X, which is TQR, has to be equal to 0. Likewise, I can apply sigma Fy is equal to 0. If I apply sigma Fy is equal to 0, what have I got? I have over here TQP is equal to 0. TQP is equal to 0, which implies that both these members are having 0 loading. So now my truss system has come down to only 2 members. If you see, one member is this PR member and the other is RS member. Now what I'll do is, in the next step, I'm going to apply method of joints for point R. Let us say, by method of joints for point R, if this over here, let us say, is joint R, where I have a force F and I'm going to have a tensile load along this thing. Let us see whether tensile compressor. Okay, I'm representing it by TRS and exactly at 45 degrees I'm having TPR, let us say, TPR. This angle over here is 90 degrees and this angle over here is going to be 225 degrees. I'm going to apply Lamies over here. By Lamies, I can say F upon sine of 45 degrees has to be equal to, you see, opposite does not exactly mean 180 degrees opposite. Opposite means, in this particular case, the angle between the other 2 forces. So F upon sine of angle between the other 2 forces is 45 degrees. Similarly, I hope you can guess now, TRS upon sine of Now what are the other two forces? The other two forces are F and TPR. Between them the angle is 225. Sine of 225 degrees has to be equal to. Lastly, I'm having TPR. TPR upon sine of. Upon sine of. The other two forces are F and TRS. The angle included between them is equal to 90 degrees. So let me put over here 90 degrees. Solving this Lamis, I'm going to get the answer. If you solve this thing, you are going to get TRS is equal to minus F. Minus over here indicates that the load is going to be compressive in nature. And TPR is equal to F root 2. Now positive sign implies it is tensile in nature. So TPR is tensile F root 2, TRS is compressive F. Let us see which option holds good over here. If you see, the first is for PR, second is for RS. I need F root 2 positive. F root 2 positive I'm having in both these cases. And F negative, I'm having F negative over here, which is for option D. So F root 2 tensile and F compressive implies the answer over here has to be option D. Option D is the correct answer. Let me write over here. The correct answer for this question is option D. Okay. Now this does not take a lot of time actually. Fine. Once you are doing these kind of questions in examination, I would not even expect you to do all these things. Straight away by looking at this diagram, you should say both these members don't exist. They are not you're not supposed to do all these things. I'm showing you over here for clarity, but if you are doing it in examination straight away, for me these two are invisible. For me the only thing left is this part now. That's it. I'll start the question straight away from there. Fine. It saves my time also. Let us look at the second question over here. The second question says, this is from dynamics of rigid bodies. Let me get out of the frame for you to read the question. The question says the wheel and axle system lying on a rough surface is shown in the figure. The figure is clear to you. Each wheel has a diameter of 0.8 meters, mass of 1 kg. Assume that the mass of the wheel is concentrated at the rim. Very, very important point. Mass of the wheel. One moment, please. The mass of the wheel is concentrated at the rim and neglect the mass of the spokes. The diameter of the axle is 0.2 meters and its mass is 1.5 kgs. Fine. Neglect the moment of inertia of the axle and assume G is equal to 9.8 meters per second square. One more important point over here. Neglect the moment of inertia of the axle. An effort of 10 newtons is applied on the axle in the horizontal direction shown at the midspan of the axle. So you have over here 10 newtons of force applied at a distance of 0.1 meters from the center. ठीक है? Assume that the wheels move on the horizontal surface without slip. That phrase without slip is very important again. The acceleration of the wheel axle system in horizontal direction in meters per second square is going to be equal to how much? What is the acceleration in meters per second square is being asked. Very simple question. Okay, but you have to over here, mark what are the important points, right? Now, mass of the wheel, let us write the data, is equal to 1 kg. And there are two such wheels we are having, two wheels. I want you to visualize these wheels over here as rings. These two are like rings. Why do I call them as rings? You see, there are 2 points which are indicating to me that they can be similar to rings. The first point over here is mass of the wheel is concentrated at the rim. So only at the periphery you are having the mass concentration. Second point is neglect the mass of the spokes. Of course, there are going to be some spokes in between over here, is it not? Otherwise, you can't have a wheel connected to the hub. The rim to be connected to the hub, you are supposed to have some spokes. But the neglection of these spokes mass is again indicating that for me this wheel is as good as a ring, right? Next thing, mass of the axle is equal to 1.5 kg given to me. These two things are given to me. One more thing, he has asked me to neglect the moment of inertia of the axle. Moment of inertia of the axle. So if I say I want to find out the moment of inertia of this entire system about the center of gravity, moment of inertia of the entire system about center of gravity, then it is going to be equal to how much? For ring, we know it is equal to mass times r square. Since I'm having two wheels, I'll write over here 2 times mass of wheel into r square. Okay, strictly speaking, I should be adding over here I of the axle also, but that is neglected. Okay, so it becomes simple for, if I calculate this value, how much would I get? So 2 times mass of wheel is equal to 1, r over here is equal to, look over here, the diameter is 0.8, therefore the radius has to be 0.4, so 0.4 square. 0.4, this is oral thing, 0.4 square is equal to 0.16, 2 times 0.16 is supposed to be equal to 0.32 kg meter square. Units very important. Okay, let us save this as some equation number 1. Let me save this as some equation number 1. This is my equation number 1. Fine. After having got the value of I, I'm going to look at two equations now. One equation is summation of force is equal to mass times acceleration. The other equation is the net torque has to be equal to I times alpha. These two equations I'm going to look at, right? Let us start with summation of force is equal to mass times acceleration. If I look for summation of force is equal to mass times acceleration, think of this. What all forces do I have? I see over here, I'm having a force which is equal to 10 newtons in the forward direction, and I'm going to have a friction force over here. In the opposite direction, I'm going to have a friction force, is it not? So now let me write summation of force for the entire system now. Summation of force is equal to mass times acceleration for the entire system. Okay, the forward force is equal to 10 newtons and the backward force is equal to friction. This has to be equal to net mass is equal to how much? Net mass is equal to 2 times mass of wheel plus a single axle, therefore mass of axle times acceleration. So I get over here 10 minus F is equal to 2 times mass of wheel is 2 plus axle is 1.5. That should give me 3.5 times acceleration. 3.5 acceleration. Let me save this as some equation number 2. Equation number. Okay. I've got two equations. First equation, if you recapitulate, I was having was I about G was equal to 0.32 kg meter square. Okay, I've got these two equations now. What now? I'm going to write net torque. Summation of torque is equal to I alpha. Net torque is equal to I alpha. I want you to visualize what all torques are we having over here. Now please imagine the torque I'm having over here is 10 into 0.1 and friction into 0.4 in the opposite direction is equal to I into alpha. So what do I have? So I'm going to have 10 multiplied to 0.1, 10 multiplied to 0.1 minus F multiplied to 0.4, F multiplied to 0.4 is equal to I alpha. I have is equal to 0.32 and alpha is basically A by R. Recapitulate, alpha is equal to A by R, right? So I can write over here 10 times 0.1 is equal to 1 minus 0.4f. 0.4f is equal to I is equal to 0.32 times acceleration upon radius. The radius now should be the radius of this entire wheel, which is equal to 0.4. Now this implies I'm having over here 1 minus 0.4f is equal to 0.32a by 0.4 is equal to 0.8a. Now you see I'm having two equations which are having two variables, f and acceleration. I see I have two equations. Let me save this as some equation number 3. I'm having this equation over here which is having variable f and a. I'm having this equation over here which is again having variable f and a. If I solve these two equations, right, I'll get the value of f as well as the value of a. I'm straight away writing the answer. If you solve this thing, you're going to get a is equal to 5 meters per second square. The value of acceleration is equal to 5 meters per second square. So whenever these kind of questions come in, you have to understand that it is a case of rigid bodies. So torque is going to be important, for which moment of inertia is going to be important. At the same time, net force is equal to mass times acceleration is something which is very fundamental. So I don't need to stress much on that. You already know those things, right? I hope you have got this answer. The answer is 5 meters per second square. The next question we are having is a question on friction. Let us see the question. The question says a block of negligible mass rests on a surface that is inclined at an angle of 30 degrees to the horizontal, as shown in the figure. When the vertical forces are 900 newtons and horizontal force of 750 newtons are applied, the block is just about to slide. Now mind you, he has just mentioned the block is just about to slide. This is a very good thing. But he has not mentioned where. Okay, as you proceed in this question, you are supposed to decide in what direction sense this block is going to slide. It is up to you, right? We'll see how to do that. Moving further, it says the coefficient of static friction between the block and the surface is how much? So this question belongs to what topic? This belongs to the topic of friction within statics. Okay, there is an impending of motion, so therefore equilibrium is still valid. Only thing that is tricky over here is you are supposed to decide in what direction since the motion is going to impend. Okay, without much discussion on this, let us straight away go to the solution. How to find the solution for this question. Let us start with the free body diagram. I have a block over here. Which is experiencing a force of 900 downward and a force of 750 over here. 750 newtons over here. Apart from this, there is going to be a normal also. A normal. Apart from normal, I'm going to have a friction force. But I can't straight away decide in what direction sense the friction is going to be there. What I'm going to do now is, without writing the friction, I'm going to decide that what direction sense the block is impending to move. And how do I do that? Let me resolve these two forces along the incline. If I resolve these two forces along the incline, I see who will dominate along the incline, and that particular direction the block will impend to move. For example, let us say I'm having 750 over here. Mind you, this angle over here is equal to 30 degrees. The angle over here is 30 degrees. This implies, let me use a different ink. This implies, because of this 750 newtons, there is a component along the incline of 750 cos 30. Now this is up the incline. And this 900 newtons is going to bring about a downward direction. It is going to bring about a downward direction, and that is equal to 900 sine 30. 900 sine 30 in the downward direction. Now, normal force is exactly perpendicular to incline, therefore it will have no component along the incline. So only these two forces are going to have components along the incline, right? So now what I'll do is, I will see who is greater. So if I compare 750, one moment please. If I compare 750 cos 30 and 900 sine 30. Sine 30, you can use your calculator. You will identify that. It is 750 cos 30 that is going to dominate. If 750 cos 30 is going to dominate, then I can say the motion is impending in the upward direction. If motion is impending in the upward direction, then friction has to come in the downward direction. The friction is supposed to come in the downward direction. So let us say this is F, which is equal to mu times N. F, which is equal to mu times N. This is what I'm having, right? Now moving further, let us now start solving the question using the equations of equilibrium. I can have summation of Fy is equal to 0. Summation of Fy is equal to 0. So what do I have now? By summation of Fy is equal to 0, I'm going to have normal's component upward, that is equal to n cos 30. N cos 30. Friction is having a component in the downward direction, and that is going to be equal to minus F sine 30 minus F sine 30 minus 900 is equal to 0. If I simplify this thing, what do I have over here? I'm having n cos 30, and this is equal to mu n. F is equal to mu n. So I can write this as n. Let me otherwise write this. N cos 30 degrees minus mu sine 30 degrees common to n is equal to how much? Is equal to 900. Is it not? It is equal to 900. Let me save this as some equation number 1. Let us save this as some equation number. Next, let us go for summation of force in x has to be equal to 0. Summation of force in x has to be equal to 0. What have I got from here? I'm having a component in this direction now, okay, forward direction, and that component is equal to n sine 30. N sine 30, and I'm having plus F cos 30. F cos 30 minus 750 is equal to 0. Minus 750 is equal to 0. Again, I can write this as n common to sine 30 plus mu cos 30 plus mu cos 30 is equal to 750. It is equal to 750. Let me take this as some equation number 2. Now you observe over here, I'm having two equations, okay. N cos 30 minus n mu sine 30 is equal to 900. N sine 30 plus n mu cos 30 is equal to 750. What I can do is, I can eliminate n from here, and I can get the value of mu. For example, from here I can say n is equal to 900. One second, let me go for the next slide. I can say, one second. From here I can say n is equal to 900 divided by cos 30 minus mu sin 30. This is the value of n. Similarly, from here I can say n is equal to 750 divided by sin 30 plus mu cos 30. Okay, both these values are going to be same. From here you can get the value of mu, and if you calculate the value of mu, it comes out to be 0.1728. 0.1728. So this is the answer to the question.